then the some of the moisture will, it means it will be less than the dew point. So some of the moisture will come out from the, it will get separated from the air, and then the relative humidity will reduce. In that case, what will happen? That example I had given you, x by y. In this case, x is reducing. So x divided by y is reduced. So in that case, why we are not increasing? Because we are at desired temperature. But by doing this process, what will happen? We are reducing the temperature. So we need to reheat the temperature to the desired temperature. So the reheating has to, in this process, reheating has to be done. And also the reheating, it means once you have used the reheating, means you once you are at dew point, okay, and 100%, it will follow the 100% humidity, relative humidity line. Then we reheat. After that, we are increasing the y to increasing and reducing the to bring back the from 100% relative humidity to comfort humidity. Is it clear? Have you understood what I say just now in this process? How we do it? So first, because yeah, tell me one day.
Sir,
Yeah.
I have some doubt. It's not clear for me how we can make dehumidifier when we are trying to keep 22 degrees Celsius and the humidity is more than 70 degree, for example, 80 degree. So how we will make this reduce the humidity? By increasing more cool or by supplying something to make the dehumidifier?
Dehumidifier means it is, we'll have to remove some moisture from the air, and it can be done once we have seen what is dew point. At dew point, some of the moisture will get separated, and if we go below the dew point, then what will happen? It will, more moisture will be removed from the air, and moisture, by removing moisture also we can uh, change the relative humidity. Let us see this relative humidity formula what we have seen. Yeah, this is the one. Now, this is the relative humidity. This is X, that example I had given you, that mass of water vapor, and mass of water vapor at saturated air at same temperature, that is Y. Now, the Y is this temperature, suppose we have reached to desired temperature. Now, at this temperature, we have a relative humidity which is higher than the desired humidity level. Then what we'll do, we'll cool it down. Once we cool it, that is dehumidification. Dehumidification means some of the vapor has to be removed from this air, and that will affect the mass of air, water vapor per meter cube of air at that temperature. So this X has to be reduced. Y is not reduced, but to reduce the X, we need to reduce the temperature. Once we reduce the temperature, we reach to the dew point, for an example. Till it reaches to the dew point, absolute humidity remains same because we have not removed any mass of water vapor. But the moment we reach to the dew point at that temperature, what will happen? These two value will become same. It will become 100% relative humidity. Once it becomes 100% relative humidity, then if we go further reduction in temperature, then what will happen? Some of the vapor will come out from the, it will get condensed and it will come out from the air, because air can hold maximum this quantity, mass of water vapor per meter cube of saturated air. It is 100% it has absorbed. Now, if we reduce the temperature, we have seen that the temperature increases, your relative humidity increases. Now we are reducing the temperature. If we reduce the temperature at one point, these two values will be same. That is the point that is called dew point. Now, if you go below the dew point temperature, then what will happen? This will be more than 100% at that temperature. What will happen? The excess difference between x can be equal to y, but x cannot be more than y because air cannot hold that excess moisture. Those moisture will get separated. Now, once the x is reduced, okay, because of removing some mass of water vapor, after that you do the reheating. Reheating means again you will bring back to the desired temperature. Then what will happen? Will there be any change in mass? After removing what the mass is remain, that will remain same. Now we increase the temperature again back to the desired temperature. Then what will happen? This relative humidity will reduce and it will come to, because now we are increasing Y, and it will come to our acceptable comfort level humidity. Is it clear, Valde?
Yes, sir.
Okay.
Now it's clear.
Yeah. Teka, tell me.
Sir, I have one question here.
Yeah, tell me.
Uh, to make it humidified, it's very clear. It's just only inject a steam or some vapor of water.
Yeah.
But to dehumidify, I mean, if there is cooler, the cooler is not the way of dehumidifying. I mean, is there any other system that we call it dehumidifier? I was thinking that cooling itself is a means of dehumidifying.
Yes, it is. You are right that it is the cooling only. By cooling only, we dehumidify. So only thing, at what temperature it will reach to dehumidify. It means you'll have to reach to 100% relative humidity or the dew point, and then you'll have to reduce that further below the dew point. Then that process is called dehumidifying because the humidity is removed from the air. Now, for the
So
cooling, it is the desired temperature up to. In that case, we are not actually doing anything with the relative humidity or the absolute humidity. What we are doing, we are increasing or decreasing the temperature to the, it means for cooler, it is we are reducing the temperature to the desired temperature. Like first we have done the cooling. We have reached to the desired temperature. But at that temperature, relative humidity has not reached to our level. It means absolute humidity was same. So by dehumidification, we reduce the absolute humidity to achieve, then reheat it to achieve the correct humidity level, relative humidity. Is it clear, Pekka? Hello, Pekka, have you understood? Okay. So this is the way the second and the third condition we deal with. And then after the reheating, we reach to the, because whenever we are doing the dehumidification, we are, your relative humidity is 100%. After that, we reheat to come to the comfort level relative humidity. And that reheating part, the mass of water vapor remains same. We are changing the temperature to reduce the relative humidity. And yeah, Petros, tell me.
Yes, Chief.
Yeah,
Moments before we have said that dehumidifying, we can make dehumidifying by making cooling. Yeah, and here we have saying in the table cooler. Yeah, this will cool the desired temperature here humidity will increase its size, and
Yes.
below its size it will decrease.
Yeah. So what is the difference? Let us,
Yes,
yeah,
I want to.
let me use the, so now, for an example, we have the temperature, outside temperature is hot, 40 degree centigrade. So now in this condition, by cooling, we reduce to temperature within the comfort zone, for an example, 24 degree centigrade. Now once we reduced, there was a relative humidity at 40 degrees centigrade. Suppose it is the 40 degree at 40 degrees centigrade, the relative humidity was 70%. Relative humidity changes, increases as the temperature increases. So at 24 degrees centigrade, your relative humidity will increase or decrease. If you see the formula, what is the formula of relative humidity? Mass of water vapor at that per meter cube of air at a particular, suppose at particular, this is 40 degrees centigrade, divided by the mass of water vapor at per meter cube of air at the saturated condition. That is 100%, how much it can hold at that temperature. So now what we have done, we have reduced the temperature. Once we have reduced the temperature, what will happen to this relative humidity? It means the 100% saturated condition, in this case, it will be less. Once it means X, suppose, is the water vapor, it is having, that is the absolute water vapor, absolute humidity, and this is Y is the capacity of the air, which varies depending on the temperature. Now at 40 degrees centigrade, this ratio is 70%. And what will happen once we reduce the temperature from 40 to 24 degrees centigrade? Our Y value will reduce, because this is the 100% vapor, how much, that is 100% vapor quantity, how much it can hold at this temperature will be higher than this. Once we reduce the temperature, this value will reduce, but our X value will remain same, because by reducing this temperature, we have not changed the value of X. So what will happen? This will, suppose it will, this value is high, constant, this is reducing, so it will, suppose, reach to 80%. Is it clear, Petros? Up to
Yes,
this?
understood. Thank you.
Yeah. Now
Yes,
what will,
understood.
yeah. So, but what we are doing for this is not dehumidification. But dehumidification, what we are doing? That time we are reducing the temperature at dew point. At dew point, what will be the relative humidity? 100%. Because this value, relative humidity value, is keep on increasing. At one point, it will become 100%. Once it become 100%, you go further below temperature. Then what will happen? It will maintain 100%, because it cannot hold more than 100%. But the Y value will be lesser than this quantity. So the difference of quantity will be coming out from the air in condensed form, because it will get condensed and it will come out. So though the relative humidity will be 100%, but this value will keep on reducing, because it has reached to 100%, because this value has reduced and keep on reducing. At one point X, this Y will become X, and that is the 100%. And if you move further, then what will happen? If X does not reduce, then it will become more than 100%, which is not possible. So what will happen? The X minus Y that difference will come out from the air, and that much means, what does it mean? The mass of water, some mass of water has come out from the air, and after that if we increase, that is called dehumidification, because some water is removed from the air. And after that we reheat to bring back, because when you do the dehumidification anytime, it will reach to 100% relative humidity at this temperature. At that temperature it would be. After that you reheat, and then you bring back to the correct humidity level. Yeah, David, tell me.
So, Chief, that means every time for dehumidification purpose, we must reach to the.
Yes, if we need to do the dehumidification depending on the outside air condition or the process it happens, we need to come to the dew point to do that. Otherwise, it will not. Understood? Dehumidification
Yes, Chief. Thank
means,
you.
yeah, that's the only way we can remove some moisture from the system.
Okay, Chief, understood.
So after that we have reheated to desired temperature, and recirculation is same. On the system we must keep on recirculation. 100% recirculation usually when we keep, as I told you last class, that is the tanker, it is during the cargo operation, definitely it will be 100% recirculation, because we don't want any contamination with the hazardous gases enter into the accommodation. The next is your another condition, that is the last condition. What is that? That is the hot and dry. Once it is hot and dry, then what will happen? The irrespective of the outside condition, we have to maintain this temperature point is same. This is, and then this is the filter. That is, the filter is common, and in this case the cooling is same. We reduce to a desired value, and then humidification, because here it is dry air. We'll have to add moisture. So what we do, we spray with through the nozzle, whether it is fresh water or this steam. So this is outside temperature is hot, so we use the water to the humidity. After that, recirculation. It is this. This is the process we do follow. If it is outside hot and dry air. Now, so these are the four conditions we'll be having. Accordingly, we'll be doing the we make the condition air to supply to the accommodation of the working place. Now this that's the reason we don't actually use all the process always. It depends what is the outside condition, and how the process during the process also it can affect the humidity and the temperature. So accordingly we use this. Yeah, they would tell me.
Yes, Chief. There is some mistake on the slides, or I'm making mistake because it shows if the outside air is hot and wet in both the slides, even if hot and wet and also hot and dry, it is still showing the same content.
So this is the dry and wet. Okay, because of the wet means the relative humidity is high. That's why we have done the dehumidification. But hot and dry, if you see,
On the
this
Chief,
is,
sorry, on the
yeah,
explanation,
yeah.
on the first.
On the explanation, say again. What do you want to say?
Yeah, if you see the hot and dry, it shows if the outside air is hot and dry.
Yeah, this
And
is
then
the
again
one.
in the next slide, it says if the outside air is hot and wet. The same explanation. It makes a little bit ambiguous.
Are you talking about this slide? This is the hot and dry. Are you referring to
Not this
this?
one. Go back.
Are you
Go
talking about
back
this?
one.
This explanation?
Yes.
Yeah, this explanation will
Yes.
remain
It should.
same. What does it mean? This is the outside, only the outside condition has changed. But inside condition will maintain same, irrespective. That is the air conditioning. That's the reason we do the air conditioning. So what is the
I
difference?
understand.
Only the outside condition is the difference. All the process it will be same, the inside condition. So now this is the one, the recirculation will be having actually what we have on board the ship. This is the block diagram. So the recirculation it comes uh, after the filter, because this is already filtered out. Fresh air only it passes through the filter, and we have one flap for the fresh air and another flap for the recirculation. We can adjust the flap. By adjusting the flap, we adjust how much it is, and there will be a marking on the handle, and there is an indicator, 0%, 100%, 50%. So accordingly, we adjust the recirculation air and the fresh air. But the total percentage should be 100%. When you adjust, suppose you keep recirculation 40% and fresh air 40%, it means it becoming 80%. So if your recirculation you keep it at 40, fresh air 60%. If fresh water you are keeping 40%, recirculation you keep it 60%. And some air, what we have seen, the stale air, that is the contaminated air, which we don't want to be in the system. So in that case, what will happen? This, how do you remove this air? This is the exhaust fan. That's why in the accommodation there are certain exhaust fan we do use. Galley, we use exhaust fan. Toilet, there is an exhaust fan. So those are the air which we don't want to be there in the system. That air will get contaminated. We cannot avoid it. What we do, we remove those air. And that air, we know how much it is as per the design, how much quantity is been removed. That has to be compensated by the pressure. And this is the schematic diagram of our air conditioning system. So the next one is, so that is as I told you, that cooking area, that is the galley, toilet, laundries. Laundry also we don't want, because there are steam used, that those steam we don't want into our comfort space. So smoking room also, those will be, if there is a smoking room, that will be having a separate exhaust. Hospital also it has to be hospital. The reason is something, that is the contamination reason. It means if a person is staying in the hospital, he definitely a sick person, so he might have that air will be contaminated. So that airborne diseases and all also come to the other room, which we don't want. That's why it will be exhaust, means it will be separate, independent system. Independent means flow, it will go move out from the accommodation. It will not come back to the recirculation. So the outside air, it means any air loss, there will be air loss, which is the exhaust, and that has to be compensated from the outside air. Now, another thing, the air we are supplying, that air should be, suppose outside air is hot, we are cooling it down and supplying to the cabins, for an example. Cabin temperature, we need to maintain certain temperature of the cabin. The supply air should be more than that, means less than that the temperature. And if it is outside is cold, then the temperature, condition temperature will be high. That has to be higher than the temperature we are going to maintain in the cabin. Why it's so? Because there will be some hot, means the heat losses or the gain. In outside, if it is cold, then what will happen? You are supplying air at high temperature, so the temperature will reduce because of the loss of heat will be transferred to the outside air. Because nothing, you cannot have insulation 100%. There will be some leakage. So that has to be considered. And not only that, there will be, suppose you are supplying cold air in the conditioned space. There will be human activities. The human being will run, suppose computer, laptop, or some other equipment. So that will generate heat. It means to maintain the conditioned air at the same temperature and the humidity level. This is the temperature we are talking about, and the humidity also. It means the temperature has to be supplied to the air temperature which is supplied to the cabin has to be slightly more in the case of the heating, in the case of cooling, slightly less. It means then only that the heat radiation and the heat generation in the cabin will be compensated. That is the, because if we mix hot water and the cold water, and then it comes to us temperature in between. So we'll have to think that way and adjust accordingly so that the room temperature is maintained. And we have seen this, the dehumidification process we have already seen. And this winter and the summer cycle, how these are the basic cycles we have. Summer cycle, for an example, we can see in our psychometric chart how it behaves. For an example, the temperature, dry bulb temperature is 32 degrees centigrade and wet bulb temperature is 29 degrees centigrade, because wet bulb temperature will be less than the dry bulb temperature. And we have got the humidity level is 80%. And specific humidity is 0.025 kg per. In this condition, if we see that the first thing, that is the position 1, this is the condition of the air which is to be processed. Now once we are processing, then air will pass through a preheater. Suppose it is passing through a preheater, but in this condition, do you need preheater? We don't need preheater because the temperature is high. Preheater will be switched off. And what the process will follow, then the air will pass through the cooler because outside temperature is high, 32 degrees centigrade, so it has to be reduced. Suppose it reduces to 14 degrees centigrade. At 14 degrees centigrade, will there be, and it is 100% relative humidity. Will there be any change in the specific humidity? And this specific humidity has become 0.01%. What was the specific humidity before? It is 0.025. Why it had happened? Because once it reaches to dew point, some of the moisture will come. This is the 100% relative humidity, and it has become this. This has reduced. It means this is the dehumidification. As well as we have reduced the temperature. Now, what has happened? Air is passing through the humidifier. Once it is passing through the humidifier, no humidity is being added because it is 100% humidity level. After that, what will happen? The 4 and 5 process, the temperature will increase. That is to comfort level, that is 23 degrees within that range. And the specific humidity, will there be any change? There will not be any change. It is 0.01 kg per kg, and the relative humidity was 100% at 14 degrees centigrade. Now it has become 52% for an example, and these two is complying with our comfort zone. 23 and 52 is okay for us, and then it goes to the cabins. So that is the way its process, actual process. The and air delivery in the room, as I told you, it should be cooler than the room temperature what we want to maintain because of those heat. Human body also releases heat. Mechanical equipment, definitely there will be some equipment in the room which will be using. Suppose you have a refrigerator, that also is releasing the heat energy. So to cancel it out. So we need to have the temperature, less temperature air has to be supplied. And then condensate, another thing is the condensate drain. In the cooler, the coil, that is the evaporator coil in the air conditioning system, at the bottom there is a drain that has to be always clear. So otherwise what will happen, if that water remain there, then that can act as a humidifier. It means that water will get evaporated and it will carry with the air which is going to the cabin. And what is the problem? There is an N notice. N notice means you act, as I told you, we are using the UK marine notices. So 1215, it's, this is the requirement for the UK flag. And all flag has got this requirement. They have their own notices. So what is the problem if it goes to the cabin with the moisture, and that moisture will get separated from the air and the insulation. There is an insulation. What we see in the cabin, that panel inside has got lagging. And that lagging will get wet and it will get damaged. That the insulation will not function. That is the reason that the condensate drain has to be always clear so that there is no accumulation of water into that condensate drain. And this condensate drain, if suppose it is not containing any water, then what will happen? Can you lose some air from that system, system which is draining? Suppose this is the drain and this is the drain. Now, because of this drain, it is drained, it will get drained out the condensate water. Condensate water will not get accumulated. So this will not be accumulated. Now,